Now we come to the final section in this chapter, which is about how can we measure the fault tolerance of flink.
So, what is checkpoint? Actually, it is just a snapshot of task or operator state. It is just like taking a picture of a person, and the picture records the status of the person at a certain time point in a lightweight way. When an error occurs, Flink can use the checkpoints to make a quick data recovery so as to improve the reliability. And the Flink processor inserts barriers as the symbol to determine when to take snapshots. Barriers are rather lightweight as well, maybe just 10 bytes or so, and they flow with the data stream without impacting the normal data analysis. When the barrier is encountered by the scheduler, Flink takes a snapshot for the current status. Apart from the checkpoint mechanism, there is another method called SavePoint. It uses the same underlying layer as checkpoint, but SavePoint is not as light as checkpoint, and the SavePoint needs to be triggered manually. And then the results can be saved to a specific storage path for persistence. Here, we can draw a comparison between checkpoint and SavePoint. As mentioned before, checkpoint are automatically triggered, while SavePoint are triggered by the users. Checkpoint can be used in cases requiring quick data recovery, while SavePoint is mainly used in backup situations like system upgrading and maintenance. Checkpoint is lightweight, and the data recovery can be done automatically by Flink. And when a job stops, its corresponding status will be cleared by default, while SavePoint can store the states in a solid storage system and recover data when needed manually. Okay, so we've learned that the states can be stored in some persistent way. And in this final part, let's have a look at state storage methods and their differences. The first and the default method is called memory state backend. From its name, we can know that Flink stores both states and checkpoints in memory, where state in task manager memory and checkpoint in job manager memory. There are some limitations in the data size, and basically speaking, it is only suitable for applications like local testing or jobs that hold little state, such as ETL. The second method is FS state backend. In this method, states are stored in task manager memory as well, but checkpoint is now stored in external file storage systems, such as local storage systems or HDFS. The limitation for data size is not strict anymore, and we can apply this method into production scenarios. And the last method is RocksDB state backend. In this method, states are stored in a built-in KV database on the task manager, while checkpoint is stored in external file storage system as well. This method has the least limitation for data size, thus it can be used in production scenarios with large amount of states. Because states and memories are stored in hard disks, its reading and writing performance is not as good as former several cases, so we just use this method in the jobs that do not require high read or write performance. Okay, so this is all for Flink. In this chapter, we mainly introduced Flink as a computing engine for both batch processing and stream processing. And the key concepts for this chapter are just 4 keywords: state, time, window, and checkpoint.
Thanks for your listening, and hope you enjoy all the contents in this chapter.